Point, and I think the other thing that has to be realized is in terms of the occurrence of hazards, there normally is a hierarchy. Uh, for example, and it gets back to your point, you lose the barrier. In other words, you put too much mud weight in, you bust through the fracture gradient. When you lose the barrier, you're probably going to stick the pipe. And then if you have any gas above you, you're probably going to get a simultaneous kick, which again is exactly what happened March 8th on the BP Macondo. So to me, part of the issue that we have in getting to your point is the ability of a system to do historical analysis. I'm a huge believer in the industry is collecting all this real-time data that is valuable in Whitsundail, and it becomes what I call digital dust. With RTAS, we can bring it to life. We can bring that out of the digital dust. We can run it in a historical mode, and then we can fast forward in a times X mode to actually see those hazard conditions evolving as they occur. So what I'd like to do, and let me turn it to Jeremiah, in terms of the ability to customize that capability, and as an experience in RTO systems, how valuable do you see that?
That's huge. And speaking to your conversation about what I'll call troubleshooting and root cause analysis. So you guys know I come from an IT background. When I was supporting a large operation, RTOC, I had a concept with my team. Because we kept running into the same problems over and over and over. And of course, everybody is worried about the minute. Get this fixed. Get me back to my data. That's all I care about. What caused it? Figure that out later. Get it fixed. And that's what we would do, is fix the problems. And that's all we ever had time to do. But eventually we said, hold on, this is just insanity. Let's actually take the time when we have these problems to understand what got us here. How did we get here? What is the ultimate root cause? And then let's address that through other procedures outside of this issue. Let's learn our lesson. In oil and gas, that doesn't exist. It's the same thing. You've got to get going. You've got to get drilling again. It's all about the money. And we don't look back and we don't say, how did we get here in the first place? And I think that this system and this historical playback and historical analysis allows you to do just that and garner lessons learned, put them back together. Because you can look at wells from 5 years ago, 10 years ago. If you've got the data, the hardest thing about it will be getting your daily drilling reports, understanding what was actually happening on an operational level at that time. But as far as the data goes, we can get it in numerous ways. And just like David said, run through the analysis and have an end result. What happened? How did we get there? And if you look across 10 different wells that are all being drilled by the same crew or the same company or whatever other commonality, and you start picking out those things that happen over and over and over, and it's linked to these commonalities, and you remove that from your operation, the issues start to remove themselves.
So what that does is, in a sense, it makes big data, if you will. I don't like that term, but it brings it to relevancy, because even if you have 10 wells with some degree of repeatability, when you have the problem well, then you can see why it actually occurred as it evolved. You can see the trends.
And
things happen in trends.
And understand if you're making the same mistake over and over.
Exactly.
We have a blindness to that everywhere.
The black hole goes away.
Yeah, it's gone. Why
It's
worry
gone.
about it?
With your system, the black hole's gone. Because right now you can take and you can do the audits, you can do the lessons learned, you can do all of this, and where does that go? That goes into the black hole. So now you've got a system now that takes all this data that we get right there. 95% of it goes into the black hole, and there's no recovery because it's gone. With your system, that completely goes away.
So, to a point, Jim Roth and also Joel, we had in past looked at in other companies that you're familiar with, a whole plethora of wells, and we began to see the value out of bringing that data out of what I call digital dust? What value do you see?
I think the best data is where you have a bunch of wells that were okay and one was a problem, right? Because you know there was a problem. If you run your program in historical mode, you basically verify to me that you can find the problem well. So there's the sales job, right? You can take somebody's digital data and show them where they had a problem and the fact that you could have identified it before you had the problem, and therefore not had the problem. That's number one. For me as the that's number one for you guys on how to sell it. For me as the operator, it's basically calibrating the model, right? Calibrate the model, find the error that I had, which is what we did, right? Show me that you could find it 5 or 6 hours before we actually had the problem. And then I now have a tool to put in front of the driller to not have that same problem again, right?
See, and that's the critical importance. You're bringing it back to the driller.
It has to be. Like, this is all around putting tools in front of the driller, putting tools in front of the drilling supervisor, putting tools in front of the drilling engineer and the superintendents, the whole level, so that everybody is on board with this, but understands the best problem to have is no problem. Let's avoid the problem.
So I can tell you of a well that you're familiar with, and I saw it evolve in the remote center one morning early in Calgary, and I walked in very early, and I'm looking at the screens, and what I see are some unacceptable trends, and the attitude in the remote center was, man, this is great, look how fast we're drilling. And yet what had happened at tower time is a new crew came on, and I suppose the driller took it upon himself to double the weight on bit. Within a stand or two, the well began the cuttings load. The cuttings were loading in the well bore, they weren't cleaning it. And I looked at it and I said, gentlemen, you're about to get stuck. So sure enough, got stuck, lost the whole section. 2 weeks later, recovered on sidetrack. So what I want to do now is kind of take a look at some of the comments you made, Joel, in terms of the value of understanding what cuttings loading means in a wellbore and how important it is.
Well, I mean, it's like you've said many times, I mean, it's the first start to major problems, right? I mean, again, everything we get is post-well, right? I mean, it's lagged, everything we're getting. And I think the issues that come about, I mean, I think what we can do is identify, the types of cuttings. Is the wellbore caving in? We can look at those based on the type of rocks we're looking at, and make some determinations like that. I think, again, the well site geologist and the gas detection equipment is a value added to the systems that are on the rig that are making these, detections. And it goes back to the proactive part. We're looking at things that are happening during the well. We may be getting sloughing in that, we're catching in the cuttings. Well, it's higher up in the well. It's not there. So we can identify those issues and bring that to light and add that in what you guys are talking about, put this back into your system. But back to the issue of, how do we get people to adopt this? I think it's pretty simple, cut and dry. You got a proactive system, right? I mean, I think everybody's here's an agreement that you don't want to wait till a kick and have it identified. You want to head those off ahead of time. But it's the old thing of the old saying of experience is the best teacher. If you can show the leadership of a company the value, they make the commitment to say, let's try it. Put it in the hands of the people on the rig. It's like you say, you never saw a driller that wanted to screw up. So once he gets that experience of using this tool and getting it in their hands, and they see on a daily basis that, hey, yeah, this is making a difference in my world, that's when people start adopting it from top to bottom.
What difference would it make if, let's pick on a major because that's easier, if a BP or an ExxonMobil advertised 1 year that they didn't have any kicks, or they didn't have any well control, or they didn't have any stuck pipe events, right? For me as an operator in a small company, if we start having no problems, and it quickly becomes known that operator isn't having problems, and the world sees our drill costs and our drill times, Pretty quickly, the question is, what are they doing different? Right? I can keep some secrets, but I can't keep every one of them. This kind of system will sell itself at a certain pace, right? If ExxonMobil didn't have any negative well events for a year, do you think they might want to advertise that?
Oh, yeah. Yeah.
Right? I mean, what a difference that would make in the industry in the US, wouldn't it?
Mhm.
Or pick on maybe a drilling contractor.
And
None of their rigs had any stuck pipe incidents in 1 year, or none of their rigs had any well control events in a year, and yet they're drilling with us. How many different rig companies around them that are having problems left, right, and center? Do you not think they're going to use that to sell?
So the perception, again, in the industry, and this is part of overcoming it since you mentioned drilling rigs, is, we don't do, and it's also operators, gee, we do better because we're trained better, we have better equipment, we have better this, and so it won't happen here. What's wrong with that statement?
It
the
does.
assumption.
Just ask Boeing.
More precisely.
When you contract a rig, you can look at their lost time incident frequency. You can look at a number of things. They're all trailing indicators, right? You don't know that the crew that just finished drilling 30 wells for another operator is actually going to be on that in whole. Most of them are probably going to be there, but maybe they've had a driller. Maybe they've had a couple derrick hands that have moved up to driller. Pick the position. It doesn't matter, right? We as an industry have to promote promotion within the industry, on the rig. So there's always going to be that people movement. But the rig that you bought for the program, if you will, or you're renting for the program, may not be the one that's on paper. Big difference, right?
Yep.
As long as you,
That's huge.
it is. So the best thing to do is assume that the best thing to do is to give the driller at that rig at that moment all the tools you can to not get stuck or not have a kick or avoid any other incidents.
Let's take it even deeper than that right there. You take, and going back to the Oklahoma, we talked about that. It goes all the way back to your rig inspection. Why didn't the BOPs function? They had hydraulic hoses on there that were rubber instead of the Cloflexes. Who would accept a rig like that in today's market? Who would put out a rig like that in today's market? That just when you come down to the basis right there, the crew did everything right as far as when they went to close the BOP.
They weren't given the right tools.
They weren't given the right tools. Exactly. So the wrong people, the wrong plan got them into that situation, and then the wrong tools is what actually got them hurt.
And you brought up a really interesting point, and again, it goes to culture in the industry. The general culture in the industry is we don't need real-time data because the rig knows best. And yet we know it's a very complex operation. We know it's very complicated. We know the training is not what it should be. So those extra set of eyes are really important. But one of the problems to me in the industry is that the conventional tools for real-time data really don't do that much. There are no analytics per se. They may be great as far as data goes, and I'm not questioning that. So then when we have a system that through pure physics measures the zero-sum balance of drilling, which cuttings always brings a well out of balance, we have a system that actually then gives the industry a tool to use that's beneficial. And I submit that one of the problems is when you talk about real-time data, then we need to qualify it and say, oh, but it has to be beneficial real-time data based on relevant data. So I think, again, how do we change that culture and the steps that are in there? And it's not just important for our task per se and our product per se. I think it's important for the industry and its license and moving forward. And and also its understanding of its own responsibility and accountability. And that kind of leads me into another part of this discussion is, what does our system do in terms of responsibility and accountability, Jeremiah, and why is that important?
That's huge. A lot of times you look back on wells and you try to figure out who did what, why did they do it, what got us here. You look at the DDRs and they give you something very, very high level. So this thing happened, why? Nobody knows, but we did it. And that's not as big of a deal when you're looking at a well that was drilled 2-4 weeks ago. When you're looking at a well that's 5 years ago, it's impossible to really know what they were thinking. So DrillSage is huge because whenever a watch or an alarm happens, users have a chance to interact with that watch or alarm. And that interaction can be driven by questions that the operator has selected and said, okay, when this happens, you need to go through this checklist. And it's usually just a simple yes/no question. And based on the answer you get another question, usually leading up to a question of, is the wellbore stable? But again, that's definable. The operator can tell us, okay, I want to ask this question or that question instead. But when somebody answers that, when somebody interacts with the watch or an alarm, we log that. We log who did it, what time they did it, what machine and IP address they were on. Everything that happens in regards to that watch, everything that's written as a comment is stored forever. They can't delete it. They can edit it, but we'll never remove what they originally said. Everything that they say, we keep a copy of. And to me, that's massive, because you always look back and you say, why did we do this? And you can't find out. And sometimes you can find out why something, sometimes you can figure out the answer, but you can't figure out the question that they were asking at that moment. And to me, a lot of times that's just as important. And how did you get there to even think about this? I don't care that you adjusted mud weight and that was successful. What made you think you needed to do that? And I think those are pivotal.
So we call that alarm management within the RTAS system. And I think we're probably one of the first systems that has attempted to really tackle that again proactively. And for example, and again, I'll go back to the Oklahoma well, there were numerous examples while either flowing and tripping when it was questionable as to whether or not the gain, for example, pit gain, was a result of transfer, simultaneous operations, or in actuality was influx. Well, when you look at the underlying data, no doubt it was an influx, but it was interpreted and even stated on as an annotation that transfer. Well, so how does our alarm management system impact and take away that doubt?
Well, continuing on your example, let's say that we get a massive shift in gain loss. The question that is asked immediately is, was this the result of a mud transfer or an active system change? And if they say yes, we ask them, how much did you actually transfer into the tank? And using that number, we can then say, okay, you transferred 75 barrels, but I've shown a 100-barrel influx. So 25 barrels of that is coming from somewhere else. And so I'm not sure if that answers your question exactly.
No, it does.
It does.
But that is critical thinking.
Yeah, that's what I was going to say, is that your program forces critical thinking.
Yeah.
And so I'm looking for 25 barrels. Where is that 25 barrels?
Right.
And people sit there and say, this goes back to the culture today though, but they say, well, that's only 25 barrels. Multiply that times 3, that's a 75 barrel influx. Now that's just taking a rule of thumb right there. So that's a 75 barrel influx. Now that you keep messing around with that, and guess what? That's now another Oklahoma.
Yeah.
That's the smallest number that there is, not the biggest.
When we were trying when we first started this concept, we had a lot of conversations with a lot of engineers who were very numbers heavy. And they always were asking questions, well, what is the exact value of that gain? What is the exact value? And one of the hardest things to convince them of is it's not the exact value, but what is the trend?